Hi, my name is Philip Thomas, Wells Corporate Trainer, and welcome to the second edition of our Design Guide series. In this video, you will learn about precast beams and how you can utilize them in the design of your structure. Beams play an important role in transferring heavy floor loads to their column supports and are critical to the overall load path of the structure. Our topics for today's video will include the following: types of beams, preliminary selection of beams, design of beams for external loads and manufacturing considerations. Precast beams can be produced in all different shapes and sizes, but there are a few specific beam sections we are going to focus on today. These beams can support not only precast elements, but many other types of construction as well. Inverted T-beams are a common element in precast construction, and they can support double T's, flat slabs, beams, or other floor members on either side of the beam. These prefabricated building components have integral ledges that carry other floor members, allowing them to be erected quickly and easily. L-beams are similar to inverted T-beams, but they primarily support other floor members on one side only. R-beams can support surrounding building systems on either side, but do not contain an integral ledge. This can be achieved in many ways through pockets or embed plates with welded steel supports. The preliminary selection of beams is best achieved by referencing the load tables provided in the latest edition of the PCI manual. Those tables make it easy for engineers and architects to understand which beam sections are most economical given a desired span length and floor loading. Understanding the overall structural depth requirements early will help maximize floor-to-ceiling heights and mechanical coordination. Precast beams typically have a minimum release strength of 3,500 psi and a 5,000 psi final strength. They typically function as girder elements and therefore collect a tremendous amount of load. As such, they can be quite a bit beefier than other floor members, as they can have very large end reactions to go along with very large spans. Shear reinforcement at the end of the members generally results in the use of closed stirrups or mesh ladders. The main flexural reinforcements are pre-stressed strands located at the bottom of the beam. These pre-stressing strands create internal compression forces that counteract the tension experienced at the bottom of the section under load. Beams are typically manufactured in steel forms that can be anywhere from 100 to 600 feet in length for larger bridge sections. They can be produced in a variety of depths and widths that vary widely among manufacturers. Lifting devices are cast in so that they can be stripped from their forms and safely handled until they are placed into their final positions within the structure. Transportation constraints such as weight and overall length should be considered early in the project timeline to avoid any issues later. Overall, precast beams are an important and high-quality product to consider when designing a given structure. Thanks for listening, and as always, don't be shy about reaching out to Wells or your local precast manufacturer to find out if precast is the right solution for your project.